All right, hello, Reese. We are starting implicit today. We are starting implicit. And this gets to be a little hairy. I'm not going to lie to you, but as soon as you got it, you got it. It's okay. Okay? We have been doing...
She definitely said, oh golly, for sure.
Oh golly. Reese said, oh golly. Okay, there we go. Thus far, we have been doing explicit differentiation, which means finding the derivative explicitly, okay? That's what we've been doing thus far. We haven't labeled it as explicit because that's all you knew, right? You didn't know that there was another method, okay? So going forward, we're going to be doing implicit differentiation, all right? So here's the deal. Let me give you an example just to preface this and just to begin, okay? Here's an example. What we've been doing before, y equals, let's say I have x squared plus 4x minus 5. I don't know. And let's say we want to find the derivative of that, okay?
Power rule.
Use the power rule, straight power rule, right? What's the derivative of y? Like, what do we label this guy as? F prime of x, or you could call it y prime, or you could call it f prime of x. Or you could call it, do you remember when they used to do like dy dx?
Over, yeah.
Yep. So that's the derivative of y with respect to x. We're going to be using a lot of this dy dx stuff this chapter. So rather than doing y prime or f prime of x, dy dx, all of those are ways of saying the derivative of y. So the derivative is equal to, and then we what?
Does it matter like
Which one you use? No. We're going to be using this going forward a lot, okay? So it doesn't really matter which one you use. I guess technically this one is labeled y, so you should probably call it y prime because that's what it's labeled to begin with. So if I do the derivative, he is 2x plus 4. Not bad, right? Like that is his derivative. Y prime equals 2x plus 4. That's how I find it. But here's the problem. Let's say I have like x equals y squared plus 4y minus 5. Let's say I have it there instead. How do I find the derivative of that? Because like you have to have y, like y equals, right? You have to have like y equals something, right? And I can't do that because like I would have to do the quadratic formula or something to get y by itself, and then we would have a whole big long mess, right? Like how do I do that? So in this case, when my variable is not x, that I'm solving for, or that I have, this is when we use implicit differentiation. Okay, boys, put everything else away. You're going to be lost. Okay. All right. So if I solve for this implicitly, again, I made this example up. Okay. We are always finding the derivative with respect to x. Like x is my designated variable. If it's another variable besides x, we have to do some special things to it. Okay. Or no, besides x. Okay, like explicitly. When we're doing explicit differentiation, we are always doing the derivative with respect to x, okay? So if we have variables other than x, we have to be careful, right? So here's the deal. When I'm finding the derivative, I look at both sides. I look at what's going on over here, and I find the derivative of the left side. So what's the derivative of x? 1. The derivative of x is 1, right? There he is, okay? Now, when I go to take like the derivative of y squared, I would do the power rule and it would be technically 2y, right? Mm-hmm. Okay? But when you're doing the derivative of y squared, Chase, put it away, like all the way away. Like all the way away so you can listen. When I'm doing the derivative of y squared, you have to think of it as though you're doing the chain rule, okay? So the chain rule says I bring the 2 down in front, I leave the y, and then I multiply by the derivative of the inside, right? Okay, what's the derivative of y though?
1.
What's the derivative of y over here?
Oh.
2x.
Y prime, right? What's the derivative of y? Y's derivative is y prime. Got it? Mm-hmm. That's what we label him as, right? So it's 2y times y prime. Got it? Do you see how that works? Mm-hmm. Kind of confusing. Plus, okay, so that was his derivative. Now we're taking the derivative of 4y, right? What's the derivative of 4y? 4, but what's the derivative of y? Y prime, right? Like normally if this was just x, the derivative would be 4. But because it's not x, we have to put y prime on the end of it, okay? What's the derivative of negative 5?
Nothing.
Gone, okay? So now one thing I notice is that this guy and this guy, there's 2 pieces on that side and they both have a y prime, right? So I'm going to pull a y prime out in front, right? And if I take y prime out in front, I have 2y plus 4. Got it? Make sense? Now what if I'm trying to solve for y prime? Divide by 2y plus 4. So I divide by 2y plus 4. And then my y prime is equal to 1 over 2y plus 4. So anytime you're taking the derivative of a variable that's not x, you have to put like y prime on the end of it, or z prime, or w prime, or whatever, because that's not your preferred and designated variable. Got it? We're taking the derivative with respect to x, okay? So that's implicit. That's how we get around taking the derivative of this thing when y is not by itself, right? Like I have x's and y's intermingled, right? Eventually we'll get to the point where we're taking the derivative of x times y, which is going to involve a product rule. We might do that here in a minute, right? It's not that bad, okay? All right, so explicit, this is an example of explicit. How would you find the derivative of that? That would be the quotient rule, right? We would do the quotient rule to that and be just completely fine. Quotient, quotient rule. And I would be just fine, okay? It would be like y prime equals, and then I would do f prime g minus g prime f all over g squared. Like that's what he would be, right? Y prime equals all that junk. That's what my quotient rule would be. Do you need water?
I don't have any.
Go get a drink. Go get a drink of water. She choked on her spit or something.
I've been sick, so I wouldn't freak out.
Okay? All right. These are examples of... you want me to wait for you?
No, it's fine. I'll
What are
just
you
go
doing?
fill it up.
Okay, go fill it up. Okay. These are 3 examples of when we would have to use implicit because the x's and y's are intermingled. Okay? So, equal sign here. All right, we've got an equal sign here. I've got x's and y's that are together on both sides of the equal sign, and we've got a mess, right? This is a scenario of when I would have to implicitly find the derivative, right? This one I have x squared and y squared together, right? And even if I solved for y, I would have y squared equals like 1 minus x squared. But then what do I do with the square, right? Like I would have to do implicit differentiation. Okay, should we try that middle one and try to do, so this one is going to have a product rule, so I'm going to avoid him right now. And this one's going to have a product rule right here, so I'm going to avoid him right now. But we can find the derivative of this guy. Let's do it. Okay, let's find the derivative of x squared plus y squared. I'm not going to subtract anything. I'm going to leave him alone. Okay, so we just go piece by piece. What's the derivative of x squared? 2x, okay? What's the derivative of y squared? 2y, but then we have to have y prime because it's not a designated variable, so we have to designate y prime equals 0 because the derivative of 1 is 0. Okay, now if I'm trying to solve and get y prime by itself, okay, we would subtract our 2x over, right? And I would have 2y y prime equals negative 2x. Then what? Divide by 2y, divide by 2y. So my full derivative, y prime, is equal to
Negative 2x over 2y.
negative x over y if I divide by 2, right? That's his derivative. That wasn't that bad, right? Okay, now, let me do this in another way, okay? So let me do this. I'm going to restart that. So don't erase. You leave yours. Don't erase what you have. I'm going to erase mine. I'm going to do that problem again, but we're going to use a different notation for our stuff, right? Okay? All right. We set up above here that y prime was the same thing as dy dx, okay? All right. Y prime is the same thing as dy dx. So I'm going to use this, and I'm going to find the derivative with everything dy dx. Got it? Okay? This is going to really put some pieces together for you. If I'm taking the derivative of x squared, this is 2x dx dx. That's just like saying I took the derivative with respect to x, right? Plus the derivative of y squared is 2y dy dx because I took the derivative of y with respect to x equals 0. Okay? Now check this out. Since I took the derivative with x, or with respect to x, dx, what's dx divided by dx? This is 1. That's why we don't have to have a special like x prime or whatever on the end of the x because dx cancels and I just have 2x I have 2x plus 2y dy dx, or you can call him y prime, whatever, just like we had before. Does that make sense? So on the end, every time we take a derivative, we're putting like a dx dx or dy dx or dz dx or whatever variable it is with respect to x, because that's what we're taking the derivative of. It's just that when we do x's, they're all going to reduce to 1. So that's why he doesn't have to have a special thing on the back of him. Does that make sense? Okay. All right, let's do a problem. Let's
What
do...
if it was 2z plus 2y? Would you still add in like a z prime to the end of
Yes,
that?
yes, you betcha.
Just
Yep, if we're
leave it
taking the
X.
derivative with respect to x, yes. Yes, then you would have a z prime on the end of it or whatever it is, okay? All right, so here's another explicit. We have y by itself, we have x by itself, and they're on separate sides of the equal sign, so we can do that like normal. We could do this. How would you find the derivative of this?
I did.
You could do the quotient rule, or you could bring the x to the top, so this would be y equals x to the negative 1, and then you could do the power rule from there, right? Okay, whatever, okay? Same thing with this thing. They say, oh, they went ahead and found it, right? If I take the derivative of this thing, this is saying y prime equals, this would be negative 1 x to the negative 2 power, which then reduces and becomes negative 1 over x squared. So that's what they got. Except they didn't call it y prime, they called it dy dx. Okay, that's how they got that, all right? If we, though, instead of doing it like this and do it as y equals 1 over x and move the x over here, we would have xy equals 1, and that would be implicit, right? Okay, so should we try this one with a product rule? I bet you could be fine. Yeah.
You can't just divide the x to the other side.
You could divide the x to the other side, but not always will you be able to do that. So this is one scenario where I could do it explicitly or implicitly. Okay, let's do this one and let's see if we get the same answer, shall we? Okay, this is a product, x times y. So we're going to have to do the product rule, which is f prime g plus g prime f, okay? F is x, g is y. Got it? So if we do f prime, what's the derivative of x? 1, right? What's the what's g? Just g. Y. Plus, what's g prime? What's the derivative of y?
Or 1.
1, and then we have to have y prime. Right? Because anytime we take the derivative of y, he has to have a y prime or dy dx, right? Times f, which is just x, and then equals
1. Or no,
0. Equals 0. Okay, so simplifying stuff. 1 times y is just y, plus, I'm going to write this, I'm going to get rid of the 1 because the 1's not doing anything. I'm just going to call him x, y prime. Okay? Equals 0. Got it? Yeah? X, y prime. Okay, we're trying to get y prime by itself. This is going to blow your mind. Ready? Subtract the y. So I have x, y prime equals negative y. Got it? Then what? Divide by x. Divide by x. So y prime equals negative y over x. What the heck? That's my derivative. That's not what we got over here, though.
Negative y over x.
That's not what we got over there, though.
So what did we do wrong?
We didn't do anything wrong. They have, their left side has y prime, basically, and their right side just has x's, okay? We have an extra y that's living right here, okay? If I go up to my original equation and solve for y equals 1 over x, true?
Yep.
Yeah? Sure. So let's plug 1 over x in here. Y prime equals negative 1 over x again. You see that?
What?
Yeah.
1 over x.
And this is x over 1. If we keep flip times 1 over x, that would be y prime equals negative 1 over x squared.
Or if we get 1 over x.
Okay, 1 over, the original equation is x, y equals 1, right? So if I get y by itself and divide the 1 over x is what y is equal to,
Okay.
right? So then I just did a straight substitution and I plugged him in there. We kept flip to the top, and then we do get negative 1 over x squared. Okay,
Do you need
he's
to
kind of a
simplify
messy
it like
deal.
that every time?
No. I'm just showing you. So I would just leave the y in there if I were you. I would just leave it as negative y over x as my derivative. But I'm just showing you that's why they're not coming out to look the same. They are the same, but that's what they would do to make them look the same. Got it?
Can you go back to that real quick?
Yeah, sure. Okay. La 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 la. We'll do example 2 and example 3, and then we'll be done. We get done at 12:30. Yeah, so we got 15 minutes. Okay. All right, it says use implicit differentiation to find dy dx, which is the derivative. Okay, dy dx. We're trying to get dy dx by itself. All right, so we need to find the derivative of 5y squared.
Why is there a sign in there all of a sudden?
I don't know.
That's what I'm saying.
I don't know. Just ignore him for now. Pretend he's not there for now. 5y squared. What's the derivative of 5y squared?
10y.
10y.
Y prime.
And then we'd need a y prime in there, right? Or let's do dy dx. Let's call him dy dx.
We'll do that.
Okay, 10y dy dx, right? Anytime we take the derivative of y, we have to have a dy dx on the end of it, right? So we did kind of like the chain rule there. It's 10y to the first power times dy dx, right? Okay, plus, all right, now let's deal with the sine. Okay, what's the derivative of sine? The derivative of a sine is cosine, okay? Cosine y, but then we have to take the derivative of the inside.
dy dx.
The derivative of y is dy dx. So dy dx, okay? Equals, what's the derivative of x squared?
2x.
2x,
dy dx.
technically dx dx, right?
Yeah. Oh, then.
But dx dx cancels out, right? So he's gone. Okay? All right, so now, we've got 2x on that side. All right, we have two pieces here. What do they have in common?
Pull out dy dx.
Pull the dy dx out into the front. Okay, and then we're going to write what we have left over. Eli, are you watching this?
10y plus cosine y.
10y plus cosine y equals
2x.
2x. Now what? I'm trying to, it says to find dy dx. That means I have to get dy dx by itself. I'm going to divide by the 10y plus cosine y.
Wait,
And divide by 10y cosine y plus cosine y.
why was I?
Okay, so final answer, dy dx is equal to
2x.
2x over
10y.
10y plus
cosine y.
cosine y. There you go, that's it.
See, this is not bad.
Yeah,
I'm trying to
it's
do
not
this
that
by
bad.
myself.
Mhm.
Yeah.
That's why. So you guys looked at this problem and then you were like, oh my gosh, why is there a sign in there? And then your brain just shuts down. Just do one piece at a time. Okay, just look at one term at a time. Just do 5y squared. I know exactly where your thought process is going. Start with 5y squared. Get him done. Then tackle the sine y, which was really not that hard, right? So, but it just looking at it all at once looks really intimidating. Don't let it intimidate you. Go piece by piece and then you're done.
Why
Okay?
is there squaredness now?
I don't know.
Why is d squared
I don't know.
y?
This is saying find the second derivative. Let's find the first derivative first and then we'll tackle that. Okay? Actually, let's just find the first derivative. We're not going to do a second derivative. We're just going to find dy dx. Okay? We're just going to find dy dx because I don't give you any second derivatives on the homework.
Oh yeah.
Okay? So we're just going to find the first derivative. All right. So 4x squared.
8x.
8x to the first power, technically.
dx.
Dx dx, technically. But dx dx cancels out, right? Like dx divided by dx goes away. All right. Minus 4y dy dx. Got it. Okay. Equals 0. Okay. Now what? I'm gonna clean him up. 8x minus 4y dy dx equals 0. Now what? We want to get what dy dx by itself.
So
Get the dy dx's on one side. Get everything else on the other.
can you divide by 8x?
Nope.
minus
Nope.
y?
Nope.
Like, 'cause it's
I'm gonna subtract the 8x over.
Oh yeah.
Can I move him over? Get the dy dx's on one side. Get the other stuff on the other side.
Then you can divide. That's
Negative
what I was trying to
4y dy dx equals negative 8x. Okay, and then
say. Now divide by negative 4y.
now divide by negative 4y.
dx
So
equals
dy
4y
dy dx equals
4x over y. I can't read my own
Mm.
handwriting.
mm,
No,
mm,
they're not the same
Why
thing.
did you-
Oh, they're not. I had two X's in my handwriting.
negative 8 divided by 4 is 2.
Cancel it out for me.
So you can do 2x over y. That's
Oh,
his
wait,
derivative.
That's cancel out. You just did it wrong.
Okay.
Yeah.
I'm just
Yeah.
overreacting.
Yeah, it's not that bad.
No.
It's not that bad. Okay, there you go.
Why did it have square root thingies then?
What?
Why were they squared?
Why were they squared? What do you mean?
I have
Like, why was
you don't
that?
want me to. Two people.
That means find the second derivative. So we would go and find the derivative again. So we could find the derivative. We could find the derivative again.
Of course I want
Yeah,
to.
let's do that real quick.
Do you want to?
Yeah, actually.
You want to see it? You want to see the second derivative? This is what it looks like. Okay, perfect. Cool. Okay, all right. All right.
Ow.
I'll match your enthusiasm. This is exciting. dy dx equals 2x over y. I'm just starting it up here at the top. Okay. All right. So for some reason, I still am not really sure why they do it, but they write the second derivative as d squared y over dx squared. I have no idea why they do that. I know. So when they're taking the derivative, okay, so we're doing the second derivative. What's the derivative of this guy? The derivative of the left side will look like that d squared y over dx squared. That's what the derivative of him is. Okay, now we're going to do the derivative of this guy. How do you find the derivative of that?
Move the y to the top. And then do the product rule. I don't know.
You could move the y to the top and then do the product rule, but then it would be like a chain inside of a product.
Got it.
Whatever.
So,
Do you want to do the quotient rule? Quotient rule is probably the only other option, right? So quotient rule, we want f prime g minus g prime f all over g squared. Okay, so f prime would be the derivative of 2x, which is 2. Leave g, which is y, minus. Okay, what's the derivative of y?
It'd just be the d. It'd just be dx over dy.
dy dx.
I said that backwards.
Yeah. The derivative of y is 1, right? The derivative of y is 1.
But it has
1 dy dx, right? And then f is 2x. Okay. All over g squared, which is y squared. Okay. Now, we are really close to the final answer, actually. D squared, I'm just going to clean them up, and then we have one more step after that. This guy equals 2y minus, I'm going to call him 2x dy dx. All over y squared. So this is what we have right now, but that's not my final answer. That's not my final answer yet.
why not?
Okay? Because I don't want this guy in here.
Oh, yeah.
I want to get rid of dy dx. What is dy dx?
Divide.
No,
We already know. Oh,
just-
we already know. It's the 2x.
2xy, so we do a little substitution. And this guy right here is, what did we say, 2x over y? 2x over y. So we just plug them in there. So we've got 2y minus, I'm going to say 4x squared over y. Can I do that? 2x times 2x is 4x squared over y. All over y squared. And then that's d squared y over dx squared.
Oh,
Yeah, that's my second derivative.
kinda cool.
Yeah, isn't that kind of interesting?
Whoa, I didn't do that right.
Now you could go even further if you wanted to.
No,
That's
we're
okay.
good.
You don't want to?
But
It's not
that's
that hard.
what the thing was asking. I was only asking
Sure,
for
right,
the second
right,
derivative.
exactly. Well, I mean, like to simplify. This is
Oh,
y squared over 1.
No.
I'm
You
good.
could take him times 1 over y squared, right? Right? If you flip him to the top. Okay, and then I distribute him through, right?
It's okay.
So equals, this would be 2 over y, because the y's are going to cancel, right? One of them. Equals, or no, excuse me, minus 4x squared over y to the third power. And there he's all better now.
Oh, okay, so.
Hey,
Wait,
Comacher,
man.
at the end of next period, can you help me with 1-7? Because I really need to get that done before this weekend.
We got time right now if you want to do it.
I want to braid angels here.
Wait, the 2y and the y squared cancel? Yeah? Okay. Sorry, I'm really behind this.
You're fine.
Actually,
So that's what he would look like. Isn't that kind of fun? That's the second derivative.
Wait, where'd you get 2 over y then?
2 over y. Oh, right here, right here. So 2y. 2y times 1 over y squared would be 2y over y squared, right? But then the y would cancel from the top and the bottom, so it would just be 2 over y.
Okay, but that's not bad.
Got it. Okay.
That's not bad.
Oh, that's kind of interesting.
Yeah, considering you're not on my hand.
Very nice, very nice. Okay, all right, there we go. That's it. That's all the further we're going. Bye, Reese.